Revit Property Lines Tutorial, From Survey Data to Accurate Site Model. Hello and welcome to our new video. Today we are talking about property lines. So let's get started. We open the site view. After that we go to Import PDF, and then we need to find the folder where the PDF we want to insert is located. In our case, this will be this example. We click Open. Set the resolution to 300 dpi, click OK. And now we place this PDF like this. We can see the data provided in the survey plan. Now we go to Massing and Site, and there we click Property Lines. We can see that we can choose whether we want to create by entering distances and bearings or create by sketching. Now we will choose the first option, create by entering distances and bearings. And when the property lines dialog opens, we can see which data we need to fill in. So we can see that here, in addition to distances and bearing, we also have N and E indicators. However, on this survey plan, we do not have those indicators. That is why we will now press Cancel. Then we go to Massing and Site, and in the Model Site panel, we click Property Line Data. Here, under Angle Display, we will turn off degrees from N/S and select only degrees. This is because our survey does not use the quadrant system with N/S, but a full angle expressed in degrees. As for units, we will leave it as degrees, minutes, and seconds. We click OK. Now we move on to entering the data. Again, we click Property Line, then create by entering distances and bearings. Now we enter the data we have. So in the first column, we need to enter the distance. We click inside the cell and enter 40.23. As for the bearing, we enter it by typing 124, space, 36, space, 50, and then the degrees, minutes, and seconds will be automatically applied. Revit automatically recognizes input in degrees, minutes, and seconds format when we use spaces between values. For type, we leave line. We click Insert to add the next line. Here we enter 15.24, and for the bearing we again, like before, type 214, space, 36, space, 50. We continue. Insert the third line 40.23, and the bearing is 304, space, 36, space, 50. And the final one. Of course, we could click Add Line to close, but we will manually enter the values from the survey plan we have. The distance is 15.24, and the bearing is 34, space, 36, space, 50. And we can see that it is now closed. We click OK and place it here. At the moment, the size is smaller compared to the PDF we have, but that is because the PDF is scaled up. So now we will perform a scale. We select the PDF, click Scale, and choose Graphical. Now we select the start and end point. And we type that the distance should be 40.23. We can see that the inserted PDF has now been reduced and everything matches. Now we will move this. So in this way we entered property lines based on the data from the survey, without N/S angles. And now we will show how it should be entered when we have N and S in the survey plan. Again, we go to Import PDF and select the example model, click Open, then OK. And we place it here. Since in this example, unlike the previous one, we have the exact parcel address, we can also enter the address in Revit. The exact address is hidden due to data protection, but we will show the process. So here we are now on Google Maps. This is the parcel for which we have the survey. We copy the address from the map and go back to Revit. We go to Manage, then Location, and here we enter the address. Click Search, and we can see that the address appears. We click OK, and now it is entered. This is important for correct sun study display and object orientation. We can see that in this example, in addition to distances and angles, we also have N and E indicators, unlike the previous example where we only had distance and angle. That is why we need to change the angle display again. So we go again to Model Site, click the arrow, Property Line Data, and under Angle Display Degrees, we select degrees from N/S. Units remain the same. We click OK. When drawing the parcel in this example, we will start from this point, meaning we will first enter the coordinates of this line. We also see that here we have two values, two different distances. One is to block corner and the other is to PC, point of curvature. The number 133.45 represents the total distance to the imaginary corner, meaning where two straight lines would intersect if there was no arc. And the number 113.37 is the actual asphalt length up to the start of the curve. Now we adjust so we can see the data for 3 lines. We click Property Line, then Create by entering distances and bearings, and we start entering. So for the first one, we enter the lower value, meaning to arc 113.37. We can see that it should be N. Then we enter the angle. 89, space, 53, space, and 4. E remains. And that is it for this parcel line. We continue. Click Insert to enter the next line. Now we need to enter the curved line, the arc. We can see here we have some data. Radius is 20, L is 31.49, and theta angle is 90 degrees 13 minutes 18 seconds. The 31.49 value is the arc length, meaning the actual distance we would walk along the curve. However, Revit's table in the distance column does not require arc length, but chord length. The chord is the shortest straight line connecting the start and end of the arc. We calculated the chord using the trigonometric formula for a chord. To get the exact distance between the start and end point of the arc, we use the formula 2 times radius times the sine of theta divided by 2. First, we divide our central angle by 2. 90 degrees 13 minutes 18 seconds divided by 2 gives us exactly 45 degrees 6 minutes 39 seconds. When we insert this into the formula, we get our first key value, 28.3391. This is the distance we enter into the distance column. Now we need to place the arc so it smoothly connects with our previous lines without any break. The key to a perfect connection is adding half of the central angle to the direction of our incoming line. Our previous line goes at north 89 degrees 53 minutes 4 seconds E. That is almost exactly 90 degrees from north. When we add our calculated half angle of 45 degrees 6 minutes and 39 seconds, we get a total angle, azimuth, of 134 degrees 59 minutes and 43 seconds. Pay attention to this key detail. Since we crossed the 90-degree boundary, we moved out of the northeast quadrant and into the southeast quadrant. Revit requires bearing format in the table, so we need to see the deviation from the south line, which is at 180 degrees. By subtracting 180 degrees minus 134 degrees 59 minutes 43 seconds, we get exactly 45 degrees 0 minutes 17 seconds. That is why in the table we do not enter north, but south 45 degrees 0 minutes 17 seconds E. Now, let's enter the values we calculated. First for the chord, 28.3391. We change from N to S. And we enter the angle, 45 degrees 0 minutes and 17 seconds. Here we change the line type from line to arc. The radius is 20. We enter that and click OK. We can see that the arc position is not correct. We go back to Edit Table and need to fix this. The reason the arc is oriented this way is because in Revit, R means the bulge of the arc is on the right side relative to the direction we are moving. The key to understanding this is that Revit always observes the direction of movement. Revit is seen from the perspective of an imaginary walker walking along the line. If we imagine that we are the walker moving downwards, meaning towards the south, and if we choose R, the bulge of the arc will be on the right side, meaning towards the inside of the shape. On the other hand, when we choose L, it will be on the left side, meaning towards the outside. We see that now it is okay. Now we enter the next line. The existing property line must be selected, and we click Edit Table, then Insert, and we enter values S and W first, then distance to PC 119.92, then angle 0 space 6 space 22. Click OK. We can see it matches the survey. We continue. We enter the next line. Again, Edit Table, Insert, we keep N and E as in the survey, enter distance 133.32, and angle 89 space, 53 space, 4. Click OK. We see that it is not correct. The line goes in the opposite direction. We go back to Edit Table. For straight lines, we cannot change left or right direction. That is only reserved for arcs. To fix this, we change N to S and E to W. And now it is correct. So here we follow this logic. If our pencil moves up and right, meaning the upper right quadrant, we enter N and E in Revit. If it moves down and right, the lower right quadrant, we enter S and E. If it moves down and left, the lower left quadrant, we enter S and W. And if it moves up and left, the upper left quadrant, we enter N and W. The surveyor marks each line as a separate entity on paper. He writes north 89 degrees east because that is how he measured it relative to north. He does not care whether you walk clockwise or counterclockwise around the parcel. Revit, on the other hand, does not just draw lines. It creates a closed loop. When we enter data into the table, we are actually giving Revit instructions for movement. Go 100 feet there. Then turn here. Earlier in our example, it said go east, and that is why the line was on the right side. When we changed it to go west, the line was in the correct direction. You might be concerned because the paper says north, but you selected south in the table. But do not worry, it is actually the same line. We are just doing a back bearing to close the parcel. As long as the angles are correct, the parcel is 100% accurate and identical to the survey. We continue. We still have one line left to close the parcel. We see in the survey that the distance is 140 and the angle is 3 minutes and 12 seconds. We click Edit Table. Here, we see that the current distance from last to first point is 139 feet 3 and 83/256 inches, and the angle is N 3 minutes and 13 seconds E. In the real world, instruments have small tolerances: wind, terrain slope, rounding. The surveyor writes rounded values, but Revit is a perfect mathematical engine. If angles and distances do not match within 0.00001 inch, it will show that gap. We enter the survey values: 140 distance, S and W, angle 3 minutes 12 seconds. Click OK. Again, it goes the wrong way. We correct S to N and W to E. And we still have a gap. Click OK. Now the position is correct, but the line slightly exceeds the starting point. So we fix that. We go to Edit Table. Delete the last row and use Add Lines to close. Now it closes exactly as needed. Click OK. As you can see, everything looks good. We have successfully created our property line. So, as we can see, compared to the original survey, we have a minimal difference in the angle of 1 second, which is negligible in practice. We also have a slight difference in length, which is normal when working with real survey data due to rounding and measurement tolerances. This is not an error. These kinds of differences are completely expected and do not affect the accuracy of the model. Now we show another method for the arc. We go to Property Line and choose Create by Sketching. Then pick lines. We use pick lines because we are using the previously drawn property shape to speed up the process. Otherwise, we would manually enter distances, and for upper and right lines, we would use to block corner instead of to PC. We use extend to corner to connect. We'll move this to the right so we can better see this other method for the arc. Then we choose fillet arc. Set radius 20. Click the top and right lines, and we create the arc. Now we place tags to check if there is any difference. We must have property line tags loaded. We see we have the same values. If there were differences, we could fix them and even convert this sketch into a table. We click the property line drawn by sketch, then Edit Table, and we get a warning that if we convert this sketch into a table, we cannot return it back to sketch. We click Yes. Now we can also edit here if needed, but we do not need it, so we click OK. Another way to enter property lines is if we have a CAD file. We go to Insert, Import CAD, select the file, in our case example. Keep settings. Click Open. Wait for it to load. We locate it. We already have property lines drawn there. We go again to Massing and Site, Property Lines, Create by Sketching. Pick lines and click the lines. We hide the DWG file. We get the same shape. We go to Edit Table and convert it into a table and see the data. When we use pick lines directly from DWG, we see that table values differ from the survey. For example, the paper shows minutes and seconds, but in DWG they are rounded. This is because AutoCAD drawings are often simplified for easier work, but these are minimal differences that will not affect your project. Now we compare the two tables. The left one is manually entered from the survey, and the right one is generated by Revit. Even though we click the same lines, Revit shows a different starting point, so the order differs, but it is still the same closed loop. What may confuse you is R and L for arcs. In our table it says L, and in Revit it says R. The reason is simple. We walked around the parcel in one direction, and Revit in the opposite direction. The most important thing is that these are geometrically identical angles. Switching north to south or east to west is just Revit's way of describing direction. We'll move this property line to align with the other two. Now let's also tag it. And one more tip at the end. A common mistake when entering data manually is entering lines in random order, which can make the parcel look broken or chaotic, like in this example. We can fix this inside the table. We simply select the row that is not in the correct position and use the up or down commands to move it. By moving lines up and down, we are rearranging the path of our walker. Once the correct logical order is set, Revit automatically connects the points and the parcel is drawn correctly. In this example, we move the third row to the second position. Why this one? Because Revit reads the table as a path. Our first line ended on the east, and third line is the only one that continues that path to the south. Always look for the line that continues spatially from where the previous one stopped. Follow the cardinal directions in a loop and you will not make a mistake. Understanding the logic of the Property Lines tool is actually your shortcut to much easier work because it allows you to achieve maximum precision and correct parcel area without unnecessary struggle. The key is to understand how Revit thinks and to follow the walker through the table. Once you understand these directions and angles, you will no longer waste time wondering why lines do not connect. Instead of fighting the table, you will know how to reorganize it in a few clicks and adapt it to your workflow, saving hours of frustration and ensuring every parcel you draw is technically correct. Understanding property lines allows you to accurately transfer real survey data into the model. Once you master the logic of direction and input order, the workflow becomes much faster and more reliable, and errors are reduced to a minimum. This is exactly the difference between manual drafting and a professional BIM workflow. We hope this tutorial helps you improve your Revit workflow. If you have any questions, feel free to leave them in comments. Don't forget to like, share, and subscribe for more tutorials.